public. We study the parabola. It's like, why can't we know without even graphing it? Why can't we already tell about it without even graphing it? Because if you can kind of predict what it's going to look like, you're going to be able to catch mistakes. You're going to be like, whoa, this doesn't make any sense. Like, whoa, based on what I entered, it's supposed to be pointing up. Why is it pointing down? Let's go back to how I entered this, right? Things like that. It's very important that you know the background, not just type it in blindly. I don't want you to be the student that I'm just going to type it in and it is what it is, right? I want you to critically think about your answers. Okay. First thing I'm going to do in this exercise is I'm going to go and scan through, and I'm going to say this is a regular, did I say regular? General, sorry. Let's stick with the plan here, right? General, not general because there are brackets. General, general, not general, right? So these three I'm going to tackle first. And so the opening of this one, I look at the leading coefficient. Remember, we're kind of obsessed with that leading coefficient. Even next year, you're going to be like the leading coefficient, right? So A is positive, so this is pointing up. The width is wide. If I asked you to explain it, it's because A is stuck between 0 and 1, right? 0.85. And the y-intercept is, there's nothing, no constant, so it's automatically 0, 0. So that's also the origin. So it's both, right? It goes to the origin. It also, that happens to be the y-intercept. Next, I'm going to do the generals first. A here is negative. It's actually negative right there. So it's going to be pointing down. It's going to be normal. Why? Because A is exactly equal to 1, right? It could be negative 1, positive 1, but it is 1, the value. And the y-intercept is just that constant 0, 5. So it's a point, right, where it crosses the y-axis. Next, A is, this is not A because it's just x. Constant, oh, it's tucked in behind here. So it's positive, it goes up. I'm just going to make a note, right, that in that case, A, which is the leading coefficient, is this number right here. This is going to be a narrow curve because A is greater than 1, right? It's greater than 1. And the y-intercept is just 0, negative 7. And I may highlight all of those later on, like where did I get that number from? So now we're going to focus on these two. This one is actually in vertex form, right? So why not identify? Vertex has one bracket, and then there may or may not be a number out here. There may or may not be. If this is 0, right, then it's just going to look like that. Okay, and this one is what? You've done this last year. Factor, that's the factored form. Remember factoring? The good old days, right? Or not? I don't know. We don't factor anymore. I don't know if I told you that explicitly, but we don't factor anymore. We use our calculator instead. But that means that I give you ugly equations that you couldn't factor anyways. Even if you tried, it'd be very hard to factor, right? So here we go. I still know that this is A right there. That's A. So A is positive, so this is still going to be pointing up. A is 1, so this is a normal curve. And the y-intercept, I don't know. Please don't say 0, negative 7, because that's not in general form. Let's do that right now, though. Maybe you already did. Maybe you figured out. So I'm going to enter this into my calculator. I don't know if you played around with the settings. Maybe you did. I'm going to go zoom 6 for now, though, right? You remember what that does? Zoom 6 gives you everybody gets a standard window of negative 10, positive 10, right? And your x, and it's negative 10, positive 10, and the y. So we go to y equals. I'm going to clear what I have in there. None of these plots is turned on, right? So there we go. Let's type it in exactly the way it looks, right? Squared minus 7. If your calculator behaves in a different way, like I'm typing it in a certain way and yours looks different, call me. It has to do with some settings at times, but that's what you're supposed to have, right? So again, these are all minus, right? Minus 4, minus 7, not negative, right? Hit graph. And this one happens to fit in our window, which is perfect. I kind of did it like that. We're going to eventually figure out that they're not always visible. Then we're going to go, what was it again? Second trace. Second trace is the go-to place to get information from your curve. Okay, second trace gets you to the calculate window. And for now, we're going to just go value, and that calls for x is equal to. And in this particular case, we want x equal to 0. And hit enter, and then we're told that y is therefore 9, positive 9. Okay, so we're going to go ahead and do that. 0, 9, and you know what? I'm going to make a note here so that when you study, you know, right? Not general, used, second, trace 1, x is equal to 0 to find y-intercept. And right now this might be a lot of information for you. Maybe it's like, whoa, right? Just write it down for now. After a while, you're just gonna know this is how you do it, right? Second trace 1, x is equal to 0, and that's how we got it. I'm gonna ask you to show your keys, and it doesn't have to be like, you don't have to say enter, enter, enter like that. I don't need to see the enters, just what are you accessing on your calculator? That's kind of like showing your work there. Okay, moving on. See, so it's not negative 7. See that? Like it's 0, 9. That's the y-intercept. Next, the factored form. Let's enter that exactly the way it is. Equals. I tend to clear what I have there. And can I just show you how I enter the leading coefficient? If you want to just look up here. To be safe, I go brackets, negative 1 divided by 3, close bracket. That's how I put a fraction. If the leading coefficient is a fraction, I put it in brackets like that. And then I go x minus 4, and then bracket again, x plus 5, like that. This, you should see that this is slightly smaller, and it's higher up than a minus. I can tell the difference because I see it all the time, but you should see the difference, right? Hit graph. Beautiful, right? Did we know it was going to point down? This is A here. Let's make a note of that. This is the value for A. A is present in all forms, right? So here we go. A is negative, so we knew it was going to point down. Looking at the value itself, that's 0.333333, right? It keeps going. So that means that A is stuck between 1 and 0. That's how you say it, right? And so this would be a wide curve. And the y-intercept, we need to use our calculator for that again. So second trace 1, x equals 0, enter. And there it is, 0, 6.67. So always round your coordinates to 2 decimals. Okay, question? Okay, I'll come and see you. So let's make an arrow here. Right? This one and this one, they were not in general. We had to do something about that. So I hope this for YouTube land. Okay, Some students will try this. They'll just try to go as close as possible to it, but that won't be good enough. Okay, so you got to have the exact, because we're able to do that, you have to find the exact value, and the only way to do that is by using the functions. Just hovering over that point is not good enough for us. Very clear? Yeah? Okay, so, and if you press trace, just press trace, you can actually, it stays on the curve if you go sideways, right? So tracing allows you to like travel along. So that's actually a good point, right? Maybe you just want to know approximately. Like, hey, I wonder. But if you want to know exactly, you got to use the function second trace, all right? There we go. Let's keep going. Okay, I hope that it's slowly making sense, and I actually, if you run into problems, I want that to happen now. So if you have problems, just let me know. Other properties that can be determined using the calculator. So the next ones are using the calculator, okay? It would be the vertex. The coordinates of the vertex, right? The coordinates x, y of the point where the parabola changes direction. It can be the highest point, which is the maximum, or it could be the lowest point, which is the minimum. To determine the coordinates of the vertex, we use this one of these two functions here. That one or that one. Let's just go find them where, let's see where they are. I hope you all have this one still on there. Just go second trace, and there they are. 3 or 4, one of those two are going to be your go-tos for it. I'm just going to say something. It's one of the two, not both. And unfortunately, the calculator doesn't know better. So let's say the parabola points down, right? If it points down, then there's a maximum, right? The only way to get to, that would be the maximum. The turning point is the highest point. If you go with minimum, it's still going to try to find it, but it's not going to be the right answer. So you got to pick the one that pertains to the situation, all right? So, how did I have this here in my notes? So if A is positive, then we know that the curve is going to look like this. Arrowheads, okay, if it's not a word problem, arrowheads on the ends. And this is our vertex right here. Or turning point. And in this case, it's going to be a minimum. Okay, and we would use second trace min, obviously, lowest point to get that one. You know how, yeah, so I'm going to go here with this one. So let's assume never crosses the x-axis. There. So this is when A is negative, right? So if the leading coefficient is negative, we know it's pointing down, in which case the vertex, aka turning point, aka in this case max, right? You find that by going second trace max. So in this case it's min, and in this case it's max. So it's just basically you need to know what needs to happen just by looking at your curve, or maybe looking at A, right? So either way, you should be able to predict which one needs to be found, needs to be used. The coordinates of the vertex provides us with 2 additional pieces of information. Maybe I will add that here. It will have a coordinate x, y, right? That's what goes without saying. It's a point. It's not an equation. It's a point, okay? So once you find the vertex, we immediately have 2 additional pieces of information. So the vertex gives us this, and it gives us this. And here's, I'm going to use two different colors here, orange and green. If you have orange and green, just stay consistent with what I have. Okay, both of these guys are equations. That stays the same. Both of these are equations, and these are kind of like imaginary lines that from time to time are useful to refer to. So there's the axis of symmetry. From now on, we're going to call that AOS at times, axis of symmetry. It's a vertical line that cuts the parabola in identical halves and goes through the vertex. Okay, goes through the vertex. So this is what it would be in this particular case. So you have your vertex right there, coordinates of 2, 3, and so this would be the axis of symmetry. It cuts it in half like this. I use a dashed line. Normally when we graph, we will not have it as part of our graph unless you really want to. But the axis of symmetry has equation x is equal to, what's a vertical line that goes through this point here? Look at the orange line, it goes through 2, right? Which is also the x-axis of your vertex. So x coordinate of the vertex. So x is equal to 2, that's what goes there. Let's go to this other parabola and do the same thing. Kind of just trace a line that's perfectly vertical, goes through the vertex again, and here's our axis of symmetry. X is equal to, you always go to your vertex for exact, and it's negative 2.3. Do you remember vertical lines in intro to Applied and Pre-Cal? You should have talked about vertical lines. It's always x is equal to a number, and your horizontal lines is always y is equal to a number. Okay. And then for the other one, the other part is what we call the equation of either the max or the min, and I use green for that. And so it basically goes horizontally through your vertex. So that would be, this would be equation of max in this case, would be y is equal to the y value of the vertex, which is 3. And this one down here, is the equation of the minimum, which is y is equal to, you go over here, look at that value, it's negative 3.5. So I'm going to clarify that the vertex, this is how we say, you can also say vertex has coordinates 2, 3, right? The 3 allowed us to find the equation of the min or max, and the 2 allowed us to find what needs to go with the axis of symmetry. Both of these are equations of a line. Okay. And then with this one, I might just go, hey, we use the y value to give us that. And then we use the x value to give us that. And I apologize, I use a software, I use Smart Notebook, and sometimes like these graphs don't always have arrowheads, and I kind of want you to know that, right? That unless there's a restriction put in place, you should have arrowheads on those arms. Okay. Can I just say foreshadow here? If the axis of symmetry cuts it in half, then the distance at any point, if you travel along that vertical line, the distance from the center to this leg or the other leg will be the same, because it's a perfectly symmetrical graph. A parabola is symmetrical. Okay, so that's important to recognize. Okay, let's keep going. The x-intercepts. We haven't talked about x-intercepts just yet because the parabola has a bit of a twist to it, as opposed to linear. Linear, there was always one x-intercept, one y-intercept. With parabolas, that changes. Okay, so x-intercept or intercepts, quadratic function can have up to, where's my highlighter? Up to 2 x-intercepts. I wonder if it's because it's an x squared. Linear, x to the 1, 1 intercept, 1 x-intercept. X to the 2, tell me that you have up to 2 x-intercepts. And I won't spoil it for next year or next course, but x to the 3, fill in the blank, number of x-intercepts, right? Notice a pattern for applied 4DS. The degree of the function tells you how many x-intercepts are possible. So if you have Miss Yosek, you know nothing. I didn't tell you anything. I didn't spoil it, right? The degree of the function tells you how many possible x-intercepts there are. So there are 3 possible scenarios. You're like, 2 x-intercepts, 3 scenarios, what's going on here? Well, you could have no x-intercepts, 1 x-intercept, or 2 x-intercepts. Here are the scenarios. I use red pen for my curve, but you don't have to. But no x-intercept would just mean that the parabola just simply never crosses the x-axis. That's just what's happening there. And so we're going to make a big dot for the vertex. And then we have the scenario in the middle where the vertex is going to be it's going to be precisely on the x-axis. And then it's going to be either pointing up, or a different scenarios where it's right on it, but it's pointing down. There's always going to be a y-intercept, no question about it, because it opens up indefinitely sideways. So at some point it's going to cross the y-axis. But when it comes to x-intercepts, 0, 1, or 2. So that would be if the vertex is here and you point downwards, or it points downwards, and over here, if you have one that crosses it twice there. And I'm going to make big dots with my pencil, right? Just to have, I'm going to extend the x-axis a little bit. 2 x-intercepts. And I'm just going to tell you, it always has to do with the vertex and which way it's pointing. So here, vertex above x-axis, and points up. So A is positive, right, in that scenario. Vertex is above the x-axis, and the graph points up. And on down here, vertex below x-axis and points down. A is negative. Oops. A is negative. And then for this one, for the middle one, vertex is on the x-axis. What will the y value of the vertex be if you're right on the x-axis? It's going to be 0. So you actually know that the vertex is going to have some sort of x value, could be anywhere, but we know that the y value will be 0. I will add here, it is irrelevant as to which way it opens. I will also say this, your vertex is also your x-intercept. You notice that? Vertex is also the x-intercept there. 2 x-intercept, vertex is below x-axis. Try to use that terminology, not saying, sometimes students say, oh, the vertex is negative. There's 2 numbers in the vertex, so which one do you mean, the y value, right? And points up. So that would be one scenario. The vertex is below and the A is positive, right? Or vertex is above x-axis, and so if it's above, then you would have to be pointing down. A is negative. I was going to show you down here how to do it, but I'm going to skip that. I'm going to jump right into the graphing part later. But this is still important, this part right here. Follow me. This line right here tells you how to find it. So that is important to highlight. It's a little bit more work than normal. Okay, so let's keep going. 7. Do you remember domain and range? Yeah, so this is domain and range. This is on page 7 for non-contextual graphs. What is that? This means if there's no word problem, then this is what goes for domain and range. Okay? No word problem. Then we use this method. Note, this will change with contextual problems, right? So it will change when we do word problems. But the domain refers to all permissible x values. So for set notation, you will say x belongs to the real numbers, or x is part of all the real numbers, right? Do you remember that? And interval notation would be negative infinity to positive infinity. So they're both saying the same thing, but interval has a start and an end. Your set notation, you need to use use these brackets if you want to use set notation, okay? That's important. In IAPR, I don't think you needed to show any brackets, but in applied, you do. So pre-cal not, applied we do for the provincial exam. Set notation. Why do we use round brackets? Because you cannot encompass, you cannot include infinity. It doesn't really have a start or an end. So round brackets when it's not included. Okay. So here it is. So that's the domain, guys, every single time. So you can have a thing on your study sheet, domain for no, when it's not a word problem, choose one of these every single time. Because X just, the graph just keeps opening up sideways indefinitely, so it's all X values that are acceptable. The range refers to all permissible Y values. Okay? So this is where it gets a little tricky. Okay, so I'm going to use highlighters again, green and pink. So I'm just going to tell you that the domain would be, let's look at all the X values that are part of this graph. So it doesn't matter if it points up or down, that is what the domain refers to, the X values. Whereas the range, refers to this, all the permissible Y values that are there. So the range is a little trickier. I'm not going to lie to you, right? So for set notation, in general, you'll say this. The Y values that are acceptable, if it's pointing up, right? So if your graph is pointing up, then you're going to follow this one. You're saying that the Y values have to be greater than or can be equal to the Y value of vertex. Squiggly brackets to close it. Okay. Interval notation would be like this. You would start at the Y value of the vertex, right here. Y value of vertex. All the way to, so if you start here and you just keep going up, right? The arrow just keeps going up. This thing keeps on going up indefinitely. So there will be infinity on the other end. And so that needs to have a round bracket. Every time you see infinity, it's a round bracket. If it's a number, square brackets because you can include it. What about a scenario when the parabola points down, right? So when it's pointing down, you will say this. The Y values acceptable would have to be less than the Y value, right? It would have to be less than the Y value of the vertex. So there you go. Squiggly brackets closed. And right now might be a little bit abstract, but once you practice, perhaps it's going to be a little bit better. And so here's another one. In this case, we would come from negative infinity all the way up to the Y value of the vertex. So this would be the Y value of vertex. And that would have a square bracket around it. Okay. Some hints here. I'm just going to say there's an X, and then there's the Y value of the vertex. Right? So that's the coordinate of this point right here. And up here, you have X and the Y value of vertex. So that's the coordinate of this point right here. So the Y value of the vertex has to be in here in one of the two formats. You choose which one you want to use, by the way. I will never make you do one over the other. So you just choose which one. Here's another important note. Note smallest first, right? Largest second. That is the rule for interval notation. So let's say you determine, hey, you write this down, 5, -2, because those are the two values that this graph is in between. And you should recognize, wait a minute, which one is smaller of the two? This one is, so that should have been first and then the 5 follows. So this is wrong. Okay, so you'd have to go -2, 5. That is correct. Or some students do this. Oh, it's 7 -infinity, Mr. Dirksen. There you go. Why? Because infinity is really big, Mr. Dirksen. I know, but we're talking -infinity, right? So this is way smaller than 7. So this is wrong. The right way of doing this would be -infinity to 7. Oops. To 7. And there's a square bracket around the number, but always round brackets around the infinity symbols, okay? It has to be the case. Information overload, I know. Get me out of here. Let's practice a little bit. So let's take this to, yeah, go ahead. Let's go to the next page. Let's put arrowheads on these graphs. Boom. You can do this, guys. Just practice, okay? I know right now it's a little bit like, get me out of here. Okay, for the domain and range, we're going to do in both notations. For set notation, is there a word problem here anywhere? No word problem, so this is how you do it. Almost right. There you go. And if the squiggly brackets look ugly, I don't care. Just make them squiggly, right? I don't even know the official name. It's probably something else, but squiggly brackets is my official way to reference that. Interval notation, this goes from -infinity all the way to +infinity. Round, round, boom, you're done. The range is a little different right now. Notice that this is pointing down, right? So for set notation, if it's pointing down, it means that the y values would have to be the only y values that are acceptable, right, are the ones that are less than this y value right here. Okay, so 2.749. Why 3 decimals? That's what Desmos did. Okay, so blame it on Desmos. We're just going to use that. So that's the. And if you said y is greater than, think about it. It can't be. There's no graph above 2.49. Oh, 2.749. There's no graph there. So it has to be values that are less than that. How does this translate to interval notation? Well, you go as low as -infinity and as high as that turning point, which is 2.749. Square bracket around the number, round brackets around the infinity. I can't tell you how often students mix these up, and I have to mark it wrong. I can't even give you half a mark, okay? So you have to just make sure you get it right in the right order. So smallest first, largest second. Try this one. I dare you to try this. Even if you get it wrong, today we don't care, because we'll try, right? Give that a try. Okay, so I'm just gonna go ahead and this one I'm not even gonna talk about. Okay, boom, done. It's the range that we need to focus on. It's going up. So y, because it's going up, that kind of should tell you, hey, that means that it's y greater than or equal to, no numbers, Mr. Dirksen. Do you mean I have to go read the number off of this? Yeah. So that'd be 5, 1, right? That's 1. Just look at the scale. So y values that are greater than or equal to 1 are acceptable. Or you can say as low as 1 and as high as infinity. Boom. That's how it changes. So there's a bit of a pattern to it. So you're going to practice that in what we're doing next. So every time there's going to be a domain and range at the end of the graph in question. All right, 9. This is where it's at today, okay? And I talk a lot because I try to explain and prepare you for it. So let's make a deal. If we run out of time, you're all going to leave, right? And I'm just going to finish that question, and your homework is going to be to finish watching and make sure you have the rest. It won't be long. And then I want you to try a couple afterwards, okay? So here we go. When it says, we're going to fill in the chart below, and we're going to show our keystrokes and everything. And a couple notes here. When using second trace functions, you might see something like this, and you have already. Some of you know what this is, right? Whenever you see something with e to the something, it's a scientific notation, right? So this in particular actually refers to a very small number. We will just call it 0. So sometimes the calculator tries to be so precise that it goes down to like 10 decimals or something like that, and we don't worry about it. So this would be the equivalent of 5.7143 times 10 to the negative 7. I would accept that as an answer, but I would not accept you saying, oh, the answer is 5.71. That would not be acceptable, right? Because it's actually 0, right? So this is approximately 0 for us, because it's shifting the decimal to the left 7 spots, right? That's how small that number is. Okay, so let's enter this into our calculator. Let's go to y equals, clear that thing, and enter. It's in general form, right? Sure. Whatever you say, Mr. Dirksen. How do you know? No brackets. Oh, okay. Before we graph, let's think about this. It's going to be pointing down. How do you know? A is negative. Okay. So let's answer some of the things we know. This is going to be down. A is negative. What is going to be the width of this compared to the normal? It's going to be a wide curve because A is stuck between 0 and 1. It's 0.5, right? What form or the form is general? And here is where we're going to start getting into a little bit of calculator / analyzing. Do we know the y-intercept just by looking at it? Yeah, it's 0, negative 200, right? Negative 200? Whoa, right? Let's just say 0c. So it's 0, negative 200. That's very small, right? Like it's way down the y-axis, way down. Will our normal window show us that? So it's pointing down and the y-intercept is way down there. We're going to have to do some changes to our window. And I told you about that yesterday. So let's go ahead and do that. Let's graph it. See what I did here? I first analyzed it, like what do I already know? And now I'm going to graph it, and I'm not going to panic because I know something. This is way down in the, so what are we going to change here? Wait, what did I do? Yeah. Just making sure I have the right. We're going to go window, and we're going to go and change the Y min, like the bottom of our screen, we want to see way more. So would it be smart to go negative 200? Because it's pointing down, right? So we're going to go negative 400. How do you know, Mr. Dirksen? I just go down further than I absolutely have to. So we're going to go negative 400, negative, not minus. If you go minus, it's not going to like it. Hit enter, and then you hit graph one more time. You have to refresh your graph. Okay. You see more, right? You can tell though this is the left leg, right? So you want to see the right leg. So what do we have to change next? X max. Would you agree with me? X max. So let's go to our window. Some of you, your wheels are turning, I can tell. What should I enter, Mr. Dirksen? I can't give you a magic formula. So I'm going to try 200. And I'm going to, so my X max, I change it to 200. Okay, everybody, do the same. Hit graph. Oof. I see both legs. Pretty good. Did I go over? Was it a bit overkill? 200 is way over here, which means 100 is right about there. Just think about it. So I'm going to go X max. I'm going to go back to my window, and I'm just going to change X max to 100. I think that'll be a better view. Not that you're going to get different answers, but it's going to be a little bit better distributed. What else do I want to see? So I see the y-intercept. I see that there are two x-intercepts, but I still want to see the vertex. So what do I need to change now? Y max. Yeah, Y max. There you go. Y max. So I'm just going to go 50. Kind of just try things. Not enough. Not enough. So I'm going to go back to my window. And my Y max, I'm going to change that to 200. What did I do earlier? Sorry. X max is 100. Let's leave that. Y max, sorry. I'm going to go 200 because I have a feeling that. So Y max. So you either change Y min, Y max, or X min, X max. The rest you don't touch. Your teachers next year might change it. I don't because it doesn't need to. And that is a pretty good view at it. How do you know, Mr. Dirksen? How do you know this is good? Because the critical points are your intercepts and your vertex. Those are the critical points you want to be able to see. Okay? So what I'm going to do here for you, I'm going to go window. Just tell yourself, I don't require this for a test or anything like that, but I'm going to type in what I used for my window. So I used negative 10, 100, so X min, X max, and then I used negative 400, 200. So you should know this is X min, X max, Y min, Y max. So that's just a reference. Okay, X min, X max, Y min, Y max. Okay, that's what I used to graph it. So now that we see it, I'm going to go back to graph. Boom, that's what I want to see. I can find everything. Yeah. For sure. Calculator, let me just pause it. With me. I want to make sure you know how to do this. We're good? Okay. The key points would be the vertex. So the y-intercept, the vertex, and the x-intercepts. Okay, those you must use your calculator for. So the y-intercept, x-intercept, and the vertex, these three things. So I'm going to highlight them. Like, do we need a calculator for this one? No, we already know what it is. Vertex, do we know what it is? No, and there's no way of doing that. And the x-intercepts, we're going to use our calculators for. So let's find the vertex here. Second trace. Is this a min or a max? It's pointing down, right? So there's actually a max in this case. It's the highest point. So I hit enter there. And at the top it says calculate maximum. This is your equation. So it's that one we want. And so watch what it's asking for. Look at the question. Give me a left boundary of the vertex. So we know the vertex is here, correct? So you're going to go scrolling left and just go to the left of it, somewhere to the left of the vertex. Mr. Dirksen, is it okay if I go like way down here? There? Yeah, anywhere on the left side is fine. So I kind of stop there and hit enter. What is it asking now? A right boundary. So you need to hover over with the cursor. You need to go to the right with the arrow and go somewhere to the right of the vertex. And then hit enter one more time. So now you've told the calculator the vertex will be found somewhere in here. So when it says guess, the calculator is just asking you to hit enter and start. So every time you see guess, you just hit enter. So go ahead. And there is your maximum. And the cursor is where you want it. And these are the coordinates. 25, 112.5. Exactly. Okay? So 25, 112.5. And we're going to go second trace max. That's what we press to get that reading. Okay, we press second trace max, and then we found this. Next, let's find the x-intercepts. This one is a little trickier, but you just go back in the notes. It will show you how to do that. I'm going to show you first. So what you do is you make y2, you're going to make that equal to 0, because that's a horizontal line along the x-axis. And then you're going to find second, you're going to press second trace. Is that small or what? Here. Focus. Second trace intercept. Intersect. It's the fifth option. So follow me, guys. We need to do at least these things before we go, and then your homework will be to find these things, and then we'll do the graphing maybe next week. Okay. So I have my graph. I'm going to go second trace. Oops, sorry. What needs to happen first? Y2 equal to 0, right? I'm jumping ship here. Y equals. You will graph a second line at y2 called, you're going to make it 0, which is a horizontal line at the x-axis. So watch this. You hit graph. You see that red line along the x-axis? So we're going to now find the intersections here, and then we're going to find the intersection there and successfully find our x-intercepts. So let's do that. Second trace, fifth option, right? Or you just press 5 if you want to make it faster. And here what I will do is I will go with my arrow cursor as close as possible to the one you're interested in. Can I go right on it, Mr. Dirksen? Sure, if you want to. If that makes you feel better, go for it. And you're going to press enter 3 times. Watch. Enter, enter, enter. And there it is, the intersection. Once it says intersection at the bottom of your screen, that's what it is. 40, 0 is our first x-intercept. 40, 0. And then comma, the next one. You got to repeat the process. Second, trace, intersect. So I'm going to press 5. Now I'm going to go sideways with the cursor, press and hold until you're closer to the other one you're interested in. Because it will go to the one that's closest to it. So if you're right in the middle, it's like tossing a coin, right? Like you want to go closer. So then hit enter, 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 and there it is. It's 10, 0. Isn't that cool? Right? So once you have the highlighted pieces, everything comes together like a puzzle. Watch this. Axis of symmetry, do you remember? This gives you the axis of symmetry, the vertex. So it's in particular the x. So it'll just be the equation x is equal to 25. Right? Boom. And the equation of either the min or the max, there's only one. We have in this case a max. And that'll be y equals 112.5. Okay. And then the domain, you close your eyes and you just do, right, x belongs to all real numbers, or negative infinity to positive infinity, bracket, bracket. And I'm going to stop after this one, but the range, it's either y is less than or equal to 112.5, or negative infinity all the way up to 112.5. Right? So negative infinity, right, because it keeps on going down all the way to 11. So your homework is do the pages that you see there. So that'd be 10 and 11. Pages 10 and 11. The key that you will see has the graph in it. So for now, you just want to fill in these tables. All right, guys? Thank you.